This next section is going to be about solving systems of three variables. So far we've been able to solve for x and for y using two equations. Now we're going to use three equations to solve for x, y, and z. So now these equations are in three-dimensional space. So let's start off with a question. So we're going to have x minus 2y plus 3z is equal to 7. 2x plus y plus z is equal to 4, and then negative 3x plus 2y minus 2z is equal to negative 10. So here's my example. Now, before we do this problem, there's many different ways that you can do this problem. You can just try whatever you want and hope for the best, but it would be useful to have some sort of strategy for you to solve all these problems every single way. Sometimes you can immediately see that things can cancel, which is great, and go ahead and do that. But what I'm going to show you is a way in which we can solve these problems a really fast and easy and cheap way. And this process always works. So what you want to do, you basically want to first label these number 1, equation number 1, equation number 2, and equation number 3. The way that I do it is I always go 1, 2, 1, 3, and then 2, 3, and I'll explain what that means. So the whole goal is that I want to eliminate this 2x by combining equation number 1, equation number 2. That's what this 1 to 2 means. So I'm going to combine this 2, and whatever I get is going to be my new equation number 2. So that's going to hopefully eliminate this part. Then what I'm going to do, I'm going to use equation number 1 and equation number 3 to get rid of this one. Okay, so these two numbers right below this x, I want to eliminate them. Okay, I want a 0 there. Then what I'm going to do, notice that when these two are gone, all I have left is equation number 2 and equation number 3. I'm going to use 2 and 3 to eliminate this one. Okay, and that will hopefully help me solve the problem. And you'll see why this works. Okay, so let's just do this problem. You can slow me down if you want. On YouTube, there's a setting where you can slow me down because sometimes this can be really confusing. Okay, especially because the next section is going to be matrices, and that's a beast in itself. Okay, so let's do this problem. First, we're going to start with equation number 1 and equation number 2. Okay, so I'm going to take number 1 and I'm going to take number 2. Okay, and I'm going to work with these two. X minus 2y plus 3z is equal to 7, and then 2x plus y plus z is equal to 4. Now the whole purpose is to eliminate this 2x, so I want to eliminate the x's. Okay, so now what can I do? Well, I can multiply this whole thing by a negative 2. And what that's going to give me is a negative 2x plus 4y minus 6z is equal to negative 14. Okay, so I just distributed this into every single term. Okay, this one, nothing's going to happen to it. It's just 2x plus y plus z equals 4. Okay, all right, so now what happens? The 2x's are going to go away. 4y and y is going to give me 5y. Negative 6z plus z is going to give me minus 5z. And then negative 14 plus 4 is going to give me negative 10. Okay, so this, since I want to eliminate this part, is going to be my new equation number 2. Okay, so when I write it out, my number 2 is now going to be this 5y minus 5z equals negative 10. Everything else is going to stay the same for now. So the top one, number 1, is still going to be x minus 2y plus 3z equals 7. Move it a little bit up. Then equation number 3 is going to be negative 3x plus 2y minus 2z is equal to negative 10. Okay, so that's what I have. So the whole purpose was that I want to eliminate this 2x, and I did it. Now this is blank, which is great. Okay, now what I want to do, I want to get rid of this negative 3x. And what am I going to use? I'm going to use 1 and 3 to get rid of that thing. So it's not going to be my new equation number 3. I don't want a new equation number 1. I don't want that. I just want these things to go away. Okay, it's a strategy. So I'm going to use equation number 1. Here's number 1 again. X minus 2y plus 3z equals 7. And then I'm going to use equation number 3. Negative 3x plus 2y minus 2z equals negative 10. Okay, so I'm going to try to get rid of this x. I'm going to turn it into a 3 because it's already the opposite sign. So this is going to be 3x minus 6y plus 9z equals 21. Okay, this one's going to stay the same. Negative 3x plus 2y minus 2z equals negative 10. Right, so this goes away. This is going to be negative 6 plus 2. So that's just going to give me negative 4y. This is going to give me plus 7z. And this is going to give me, well, that looks like there should be a 7. That should be an 11. Okay, so this is going to be my new equation number 3. Okay, so I'm going to put that in there. So my new equation number 3. So number 3 is going to be negative 4y plus 7z equals 11. And everything else is going to stay the same. The first one stays the same. Equation number 1 is still x minus 2y plus 3z equals 7. Number 2 is going to be what it originally was, 5y minus 5z equals negative 10. And then I have equation number 3. Okay, I'm almost done. Kind of. So now what I did is I eliminated. So now x is by its little lonesome. Now it's gone. All of them below it is gone. Now I want to get rid of this negative 4y. Okay, so what am I going to do? What is the last one that I got to do? Is 2, 3. So I'm going to use equation number 2 and 3 to get rid of this negative 4y. So if you see, I started off with 3 variables. Then I'm down to 2. Here I only want 1. That's exactly what I want. So I'm going to use these 2 equations. Okay, these 2. So I want to eliminate this this y. So here we have an elimination. We need to convert them into a lowest common factor. So in this case, or multiple, in this case it's going to be 20. So I'm going to multiply the first one by 4, and I'm going to multiply the other one by 5. Okay, so what I'm going to get for the first one is 20y minus 20z equals negative 40. And for the second one, I'm going to have negative 20y plus 35z is equal to 55. Okay, and what am I going to get? This goes away. I'm left with 15z, okay, is equal to 15. So z in this case is equal to 1. That is my answer. Whew. So I just solved for one answer. Wow. Okay, so let's recap. Number 1, that was x minus 2y plus 3z equals 7. Number 2, that was 5y minus 5z equals negative 10. Number 3, that's going to be the new one that I got, z equals 1. So now that I know what z is, I can plug it here to solve for y. So you see what I did? Now I know what z is, I can solve for y. Once I know y, I can plug it here, and I can solve for x. Okay, so I'm going to have 5 times 1 minus 5 times z equals negative 16. I get 5 minus 5z equals negative 16. I subtract the 5 to the other side. Okay, so I'm going to get negative 5z. Okay, is equal to, oh, that should not be a 16, that should be a 10. Okay, it's going to equal to negative 15. Okay, and then I'm going to take, oh, there's a mistake here. Hold on, I messed up somewhere. Oh, I see. Okay, so I know what I did. You know what I did? You can rewind and see what I did. So this is not right. So what I'm going to take, I'm going to take the second one, 5y minus 5z equals negative 10. Okay, so I'm going to have 5y minus 5 times 1 equals negative 10, because z equals 1. Plug it into the wrong one. 5y minus 5 equals negative 10. Then I'm going to add 5 to both sides. This goes away, so I'm left with 5y equals negative 5. Okay, now I divide by 5 to both sides, so y equals negative 1. Now that I know what y is, I can now figure out what x is. Okay, so now I'm going to plug it into the first one. So we know x minus 2y plus 3z equals 7. So I'm going to plug everything in. So I'm going to have x minus 2 times y is negative 1, plus 3 times z is just 1, equals 7. X, negative 2 times negative 1 gives me positive 2, plus 3 equals 7. X plus 5 equals 7. Subtract by 5 to both sides. X is equal to 2. So now my answer is going to be an x, y, and z format. So you're going to have 2, comma, negative 1, comma, 1. Okay? Whew, that was a lot of work. But yes, you will have, there are other methods that you can do, but this one will always work. Okay? So, if you'd like, go ahead and practice this problem. Okay, so I have x plus y plus z equals 2. Negative 2y plus 2z equals 2. 2x plus 2y plus z equals 3. So you can practice this problem if you'd like. In the next video, I'm going to do a different type of problem when you have infinitely many solutions. I forgot what the answer was for this one. I think it was 101. So why don't you try it out? Use the same process. If you need to watch the video again, watch it. In the next video, I will do one with infinitely many solutions, and then I will show you matrices.